Well, I've been spending all my time here in Dr. Tom's laser lab, and he works with various areas of spectroscopy. What I've been most concentrating on is actually a very new field called terahertz spectroscopy. And it's a way of generating broadband terahertz radiation from wavelengths of about 30 gigahertz to 3 terahertz. And this is actually a very new technique. It's only been around for about the past 15 or 20 years, and it's exciting from other techniques in that it actually happens to be a phase coherent technique. So what you can actually measure with this is the complex dielectric spectrum of an object. And we've been concentrating the field mostly into actually looking at water. Water is one of the most prevalent substances on Earth, but unfortunately it's actually one of the most least understood substances on Earth. And with this new frequency range that's opened up, we've actually been able to probe the picosecond dynamics of water and actually try to understand what goes on for small water clusters. This has got some very interesting applications, not only just from a basic physics point of view, but also it's got implications into chemistry, since all chemistry is going to be taking place on this time scale. It's also got implications in biology and geology, and actually is a very far-reaching field. As a matter of fact, it's actually been integrated into part of a very exciting program here at UCR called the Environmental Physics Program. And the whole goal of this program is to actually take interesting environmental problems and apply concrete physics techniques to them that have never before been used. And in this program, I actually also have an advisor over in the environmental science department, and I am jointly pursuing, well, I've completed my PhD now in physics, but I'm still finishing up a Master of Science in Environmental Science, looking at water confined in zeolite systems, which is a type of natural dirt. Well, actually, my research has a very exciting application that's just coming up, and what I am doing currently is I am writing a proposal for what's called the Research Associate Program. And this is actually a postdoctoral fellowship grant to work at Jet Propulsion Laboratory in Pasadena. And what they want to do is they want to use my techniques and my information to be able to look for water on other planets. The goal, of course, being where there's water, there can possibly be life. And the entire idea behind this is to build a terahertz spectrometer telescope that can actually see water, not just on the surface, but can actually look underneath the surface of the soils and rocks and find water hidden away. And that, of course, is where life is most likely to exist if it does exist on other planets. My project has actually been a very interesting project, and I've had the ability to build it from the ground up. When I walked into the lab, it was actually an empty lab. All it had in it was a table, a laser in a box, and a bunch of diagrams on how everything should go together. And so my experience here has actually been one of the most complete experiences that a graduate student can have, in that not only have I built up an entirely new system whose capabilities are unique, and it's the only terahertz spectrometer in the world that can look as low frequencies as we look, which is sub 100 gigahertz. Okay? So I've been able to build this up from the ground up, from a clean table, and also been able to use it to perform the most precise measurements ever done on water, and have actually found some interesting features in water itself, in that the dipole-dipole interactions of water seem to exist on a network that actually exceeds the hydrogen bond network of the local water molecules themselves. And this has never before been seen, never even really been thought of in the past. So we've actually had a very exciting project and a very detailed project, and the ability to work with water and to work with environmental samples has actually positioned me to where I've become pretty desirable in the spectroscopy community, because my abilities with environmental samples are very rare, and my abilities with physics techniques are very well developed by this point.